I'm Anil Kumar. We'll discuss inverse relation in this particular video. Normally, inverse equation is written in two forms. One in general will be y equals to k over x, and the other form is kind of rearranging the same equation. We'll cross multiply and then we'll write the product of x and y as equals to constant, right? So these are two forms in which we normally write inverse relation. Now what does it really mean? It means that if x increases, y decreases proportionally. Right, that constant gives you that. So k is a constant. And remember here in this equation, since x comes in the denominator, we should write that x is not equal to 0. X cannot be 0. Also, you could have written this as x is inverse to y, so y will also never be equal to 0. So that is important to understand. In inverse relation, the two variables we're talking about cannot be 0, right? This is very important to understand. So it really means that if I increase the value of x, let's say x is 1, in that case, and constant is 1, for example, in that case y will be 1. But if x becomes 10, then y becomes 1/10. It decreases. So as you increase the value of x, y value decreases, right? So if x increases, y decreases proportionally, and similarly if x decreases, y increases proportionally, right? And the constant of inverse relation is non-zero, which you are writing as k in this particular case, right? So let us take few examples and identify that whether these examples do show us inverse relation or not, right? Let me take two examples. For example, I have a table of values for x and y, so I'll take two examples here. Let us say we have x values and y values. X values are, let me take them as 1, 2, and 4 for both. Let's take x values are 1, 2, and 4. And if I take the y values as, let us say, 5, 10, and 20 in this case, and let me take y values here as let's say 16, 8, and 4. Okay, now these are two different relations. You need to figure out what kind of relation do they represent. So the first one here is, if x is 1, y is 5. If x is 2, y is 10. So what we see in this case is both are increasing, right? Both are increasing. So if x increases, so if change in x is positive, it means increasing, then change in y is also positive, right? So both increases or both decreases. Do you see that, right? So that is a kind of relation. Now, how do we find y from x? If I multiply by 5, we get the value of y. So we could write y as equals to 5 times x in this particular case. How about here? Now in this particular case, we notice that if I multiply x and y, what do I get? If I multiply 1 and 16, let me make a column here. X times y is how much? So if I multiply 1 and 16, I get 16. If I multiply 2 and 8, I again get 16. 4 times 4 is again 16. That is to say that x times y is always 16. So we could write y as equals to 16 divided by x. Now, if you compare this equation with the inverse relation equation, you will say, well, in our case, the constant k is equals to 16, and this represents inverse relation. Do you get an idea? So, in inverse relation, we also find that the product of two variables is always constant. However, on the other side, we were talking about direct relation. So in direct relation, the x value increases, y also increases. If x decreases, y decreases. Here, we find that if I move from 2 to 1, that is changing x value to lesser value, y becomes higher, right? So that is one way. So definitely, this one is not inverse because they are going in the same direction. Now, this one could be inverse. If it is inverse, in that case, their product should be constant, which we found it was constant to 16. And that is one way to figure out from the table of values that the relation between the two is inverse, right? So the relation between the two is inverse if product between the variables is constant or y is equals to some constant divided by x, right? This comes from the very basic definition. You would also figure out inverse relation from a graph. Let me sketch one. If you have an inverse relation, then the graph could be of one of these kinds. It could be like, if you have discrete values, I mean some values, it could be kind of like this. This shows that if x is increasing, let's say we have x here and y on the y-axis. As x increases, y decreases. As x approaches 0, y approaches a very large value. However, x and y both can never be 0. Do you see that? So these are the conditions which we have understood and can be seen on a graph. Remember, x and y could take negative values also. So you could have a graph this side also, right? You could have a graph in this side also, right? So if x is negative, y will be negative, correct? There's no change in sign. So these two graphs are when the k value is positive. However, if we have a negative k, in that case, what will be the graph? Well, if the k value is negative, then the graphs will be kind of reversed. Then for negative x, we'll have positive value of y, right? So these will be the graphs when k is a negative value. Do you understand? It is negative. Then we have graphs like this. Since if I multiply x by a negative number, right, then I get y as negative. So for a positive x, we get negative y, and for a negative x, we get positive y. So the graph of a linear relation could be one of these four. Do you see that? Or combination of these. But in all these graphs, one most important thing you will see is that the origin is not on the graph, right? So important thing is that the origin is never on the graph of inverse relation. So that is very important to understand, okay? So with this, I hope you understand that inverse relation can be shown in the form of an equation as y equals to k divided by x, or product of x and y equals to a constant. In this, none of these quantities can be 0, nor can x be 0, y be 0, nor can k be 0, right? In inverse relation, as x increases, y decreases. If x decreases, y will increase. And if you are given table of values, you can find product of x and y. If you get a constant, it means it is inverse relation. Is it okay? On a graph, we'll kind of have 1 over x or a reciprocal function graph as shown here. Depending on the value of k, the quadrant in which the graph lies will be determined. So if k is positive, then the graph will be in quadrant 1 or in quadrant 3. But if k is negative, then the graph will be in quadrant 2 or in quadrant 4, right? So I hope with this you have understood what inverse relation is. We'll take a few examples and applications. I'm Anil Kumar. You can always share and subscribe my videos. Thank you and all the best.